Welcome back, everyone. Thank you for joining us. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, Apple Valley.
Science and Technology Channel.
Yes. So we've had some comments calling us Chinese propagandists because we had the optical, 100 gigahertz and that Chinese undersea station. Okay, we're not just because we report on an article from China, from researchers in China, doesn't mean we're propagandists. If we report on an article from Antarctica, it doesn't mean that we're imperialists. If we report on an article from NASA, it doesn't mean we're conspiracy theorists.
Look
Okay?
how look how many times we've reported on stuff that's developed in Europe or in the U.S. I
Or
mean,
Japan.
we just
Japan.
talked about stuff from the U.S., right? You were all about the U of A, right? You're a big fan of the University of Arizona, right? So we just talked about that. So yeah,
Yeah.
we're all over the globe. So yeah,
We're
I
not
don't even know.
propagandists. We're
I
just
don't.
science and technology, man. That's it.
Yeah, I don't even know Chinese. So just
No, neither do I. I don't think
yeah.
I know anybody that's Chinese.
Oh, I do. And my wife
Okay.
loves Chinese food,
Oh,
but
okay.
that's as close as it gets. So,
Okay. All right. Well, today's subject, I got a lead from my buddy Kalen. Kalen, this is a shout out to you. Thanks for this lead. I appreciate it. And the title was Applied Oil Technology, Mechanical Engineer's Dream. That doesn't mean that he dreamed it up. It means it's a dream come true for mechanical engineers. Really, this is
is your
mechanical
is your
engineering.
buddy is your buddy a mechanical engineer?
No, he works BNSF. He's a railroad man.
Oh, okay.
Yeah, good
Because
good guy though.
I mentioned it before. My dad was a mechanical engineer, but yeah, that was his
Yeah.
education.
Okay, before the development of applied oil technology extraction methods, oil was transported through pipelines using slow, inefficient, and costly methods. Initially, way back in the day, wooden pipelines were used, which were later replaced by iron and steel pipelines to speed up the process. Scott, you have experience with wooden pipelines.
Yeah, one of the places where I love to go fishing, which is up in the Eastern Sierra, on the western side of the Owens Valley. The Southern California Edison used to have wooden pipelines from some of the the alpine lakes that they would use to draw water down to hydroelectric plants. And just recently, and I say recently, probably within the last 15 or 20 years, maybe a little longer than that, they replaced those wooden pipes with concrete line and concrete encapsulated steel pipe. But they've left some of the sections of wooden pipe there that for people that can go up there and actually see what it looked like. Because I mean, it looked like basically it was like a giant barrel that was miles
Yeah.
long. So
Yep.
very cool. But
Yeah. So pipelines are the most common and important method of transportation of fluids. Back in the day when oil was first discovered, they pumped the oil into barrels. They'd load them on railroad trucks and not trucks, railways, and rail them to wherever the oil needed to go. Now it's pipelines. To
right,
enhance the flow output along the pipeline requires reducing viscosity and suppressing turbulence simultaneously and effectively. According to research from Temple University, electrorheology accomplishes both goals simultaneously. Would you like to know more?
okay, so when a strong electric field is applied along the flow direction in a small section of pipeline, the field polarizes and aggregates the particles suspended inside the base liquid into short chains along the flow direction. Such aggregation breaks the rotational symmetry and makes the fluid viscosity anisotropic, which is having a physical property that has a different value when measured in different directions. I'm glad that was thrown in. A simple example is wood, which is stronger along the grain than across the grain. So that makes sense.
Yeah, so you turn the wood, the 2x4, so the long way on the ground, and it'll crack and break. But you turn it up on its spine, it'll hold up just fine, like the rafters.
Correct.
Okay. In the directions perpendicular to the flow, the viscosity is substantially increased, effectively suppressing the turbulence. Along the flow direction, the velocity is significantly reduced, Thus, the flow along the pipeline is enhanced. Recent lab experimental tests and field tests with the crude oil pipeline fully confirmed the theoretical results.
Pipelines are the foundation of our liquid energy supply. Domestic crude oil has traditionally been collected by pipelines from inland production areas. Imported crude oil also arrives in the U.S. by marine tankers, often moving for the final leg of that trip from a U.S. port to a refinery by um, pipeline. So, yeah,
Right.
so when it gets to the port, they offload it and then they shoot it across wherever it needs to go in a pipeline. Much more, obviously, no transportation expenses or anything like that. So, in fact, we have a natural gas pipeline that runs along the Interstate 15 freeway just out of town here. I don't know how far it goes, but you can see it every once in a while. It surfaces, and there's an area there. So we just had a special guest.
Yeah, that was my wife. She picked up her glasses.
That's all good. Anyway, so yeah.
Yeah. So the United States consumes millions of gallons of crude oil every day. High viscosity of these oils becomes a critical issue. Not only the heavy crude oil has a high viscosity, the offshore crude oil also has very high viscosity because the deep water temperature is very low, about around 1.5 to 1.6 Celsius. The high viscosity makes the pressure required to pump crude oil via pipeline very high and creates many difficulties in oil extraction too.
The dominant transport methods were heating and dilution of crude oil with gasoline or diesel. The heating method is slow and energy consuming and raises concerns about its environmental impact. Moreover, for the offshore crude oil, it is very difficult to utilize the heating or dilution methods.
Okay, here's where we get into the thermodynamics, the flow of this. Crude oil is a mixture of many different molecules: gasoline, kerosene, and diesel. The liquid made of small hydrogen molecules have very low viscosity. If the remaining large molecules, paraffin particles and asphalt particles, are treated as suspended particles in such low viscosity base, then this is called a liquid suspension. These suspended particles are typically at the nanoscale, very small, but whether it's huge or small, it has the same physical properties.
Okay, so we're looking at screen one here now, right?
Yep,
Slide one. In the
yep.
figure on the screen, the crude oil flows from bottom to top along a pipe. Initially, the nanoscale particles are randomly distributed, and the viscosity is high, the bottom of the tube. When
Yep.
the oil passes a strong local electric field, two parallel metal meshes, the suspended particles are polarized by the electric field. The induced dipolar interaction forces the nanoscale particles to aggregate into micrometer-sized short chains or clusters. Once they pass the electric field, they have high polydispersity and a large size.
Yeah, so that electric field is making them coalesce together, right? Again, not at the nano, but now at the micrometer scale. So they're a little bit bigger because they coalesce together. After formation of clusters along the field direction, its molecular alignment is parallel to the flow direction, which breaks the rotational symmetry, making the viscosity of the crude oil anisotropic. Along the field direction, the viscosity is significantly reduced, while the viscosity along the direction perpendicular to the field is actually increased. This fact is very important and very useful as it does not only improve the flow along the direction, but suppresses the turbulence inside the pipeline.
Hmm. QS Energy now pioneers the use of AOT technology. Initially, they developed a high volume AOT viscosity reduction pressure vessel called the AOT XL to improve flow efficiency within an existing crude oil offloading marine terminal.
Does that sound familiar? The XL pipeline that they talk about, that Trump, it's not the same thing, but XL should be familiar to you.
Yeah, that's the one that came down from Canada that was going to go down
Yeah,
to
yeah,
the Gulf of America.
yeah.
And our Trump's predecessor, Nick
Shut
set up
it down.
Yeah, Nick said I
Let
would do.
the guys that are out of work, let them program code,
Yeah,
right?
yeah. Give me a break. Okay, so the AOT XL was fabricated to meet a target of 25,000 barrels per hour capacity, which equivalents to about 600,000 barrels per day. So, I was going to look up before we did this. I don't know what is in a barrel of oil. Is it 55 gallons or I
Yeah,
don't know.
55 gallons,
Is it
55
okay?
gallon drum.
Standard
Yeah.
barrel. Okay.
Yeah. Yeah. So according to their website, this is QS Energy, the pipe segments are pre-manufactured in 9-foot lengths and up to 60-inch diameter with flanges on each side to allow for tight placement of that system. So when I say up to, they can go bigger, they can go 30-inch diameter, 40, whatever the customer needs.
Yeah.
Any number of the AOT XL vessels can be installed in parallel to accommodate a customer's flow rate requirements. More oil can be pushed through a pipeline at lower pressure without fossil fuels to heat it up. It's a win-win. Prices for gasoline should start coming down, right? You'd think?
You would hope so.
Yeah.
Pretty labor intensive though if it's flanged together. So I mean, a
Well, no, you
60
set it
flange,
in just like an underground pipe. You set it in, nut bolt group, tighten it up, and you do that for the 50 bolts that are around it or the 30 bolts that are around it.
well, yeah. There's going to
So
be
it
more
keeps
than
it
30
tight.
volts, probably a 60-inch diameter pipe. That's going to be. I mean, there's
But
usually. Go ahead.
it is labor intensive, but
Yeah.
you have to have the local electric field at certain segments. It can't be like at the beginning and the end. It's got to be certain segments so it can keep pushing the stuff through quickly.
Gotcha. So
This is
yeah,
actually fascinating technology.
yeah, and like you say, hopefully it'll bring the price of what we use, which is gasoline. It will start bringing that price down, which I believe the prices have. Maybe not here in the People's Republic of California, but other places, the prices have started to come down since the beginning of the year. So that's a
If
good
you
thing.
can get more oil quicker to the refinery, then they can pump out gas faster, which would the supply goes up and then the price comes down.
Yep. Yeah, because the demand is not going anywhere, right?
It'll stay steady. That'll stay
Yeah,
steady.
we'll pay whatever we have to pay because we travel, whether it's to work or to recreate or to haul material, haul goods that we buy. I mean, we're a gasoline consuming, diesel and gasoline consuming society, so that's not going to happen. But the demand is not going to go anywhere. But the supply, like you say, if we increase the supply, that should bring the price down, which is what we want.
All right, folks. Thanks for joining us. We'll catch you in the morning. And another shout out to Kaylin. Thanks for that idea.
Yep. Take care, everyone. Thanks.